All right, folks, welcome to another round of physics problems. I am your host, Mr. Schrago, and today we are going to be doing formative assessment 3.2. Now, these problems were all about our horizontal projectiles. And those horizontal projectiles are always an object that is shooting off the edge of a ledge, or is being shot from a firearm, like held perfectly horizontally, or is being like thrown perfectly horizontally, which is a little bit hard to do. But no matter what, they're always going straight off the edge. So, there's a couple things that this tells us. One, it's a projectile. So projectiles are always only under the influence of the force of gravity. And since projectiles are only under the influence of force of gravity, we know that they're going to all share the acceleration due to gravity of negative 9.8 meters per second squared. Now, your physics teacher, depending on who they are, may make this a positive number. My classes, we make down negative, g is negative, and the distances the object is falling are negative. If your teacher's been doing positive, just keep it all positive. That's just how we're going to have to handle that one. So, I use a as negative 9.8 meters per second squared in my classes. But no matter who your teacher is, v1 is going to be the same throughout, because v1 is always our initial velocity in the vertical direction. And whenever we have one of those horizontal projectiles, right, it's like sitting there about to be shot off a ledge. It's not going up. It's not going down, right? Its initial vertical velocity is 0 meters per second. This is going to be something that's true about our horizontal projectiles, and so we're going to need to remember that in every one of our problems. What I like about that is I don't even need to read problem 1 before doing some of the steps. In problem 1, we've already given you a as negative 9.8 meters per second squared there. You'll see that in general we're going to use that negative number. And v1 is going to be 0 meters per second. So without having to even read our problem statement, we're able to figure out what our numbers are. All right, so you're spraying water here out of a garden hose held perfectly horizontal. That's kind of what told us that v1 here is going to be 0. The water sprays a horizontal distance of 3 meters. All right, well, so we're going to look for some keywords here, right? I see horizontal distance, so that tells me probably that I should be on this horizontal side. And now, right here, I've got 3 meters, and I'm just going to go ahead and put that in. Now, don't fall into the trap here, in that we say the hose is 1.2 meters above the ground. All right, sometimes people see horizontal, and they try to put all their numbers into horizontal after that. We have a couple key pieces of information here related to distances in both horizontal and vertical. So we have to kind of look into it. We can draw ourselves a little picture. Here's our person, right? They've got that hose, and then they've got water spraying out of that hose. And that water is landing 3 meters away. And the hose was 1.2 meters up. And so sometimes I like to draw a little diagram like that to help remember where all the information goes. But it's nice to double check it. And you can look and you can be like, oh, if I'm in that water, I'm going to fall that 1.2 meters, so I need to make that a negative 1.2. That's going to be one of the most common mistakes that I see from some people, and is that they're not making their distance negative. Because we need to remember, we're not talking about how high up that object was, but how far it fell. And falling is the downwards direction, and down is the negative direction. So, our vertical distance there is going to be negative 1.2. A handy way to know that you made a mistake is if you're trying to take the square root of a negative number at some point, that's going to be your hint that you made a mistake. And that's okay. You'll just want to go back and find it. And it's probably here. All right. We want to know what is the horizontal velocity of the water. Oh, well, then we're going to go over here to VH for velocity horizontal. That's our question mark. Now, with any of these sets of problems, we always need to start by finding time, right? We're never going to give you time to start out with, and that we're not going to ask you for time. But you will need to find time in order to get to your answer. So in order to do that, right, we need to look for where we have enough information to solve for time. We'll look at the horizontal side. If we know XH and we know VH, we can start on the horizontal side because the horizontal side is X equals VT. That's handy to start, and so I always start by checking that. Unfortunately, we don't know VH, right? We don't know our horizontal velocity. That's what we're searching for. So we're going to have to start on our vertical side, which is always X equals 1/2 AT squared plus V1T. And this is where we're going to have to go if we want to solve for time. You can go ahead and you can cross out V2 because we don't know it. We haven't asked you for it. We don't really care about it. All right. So as we are over here, we've got this x equals 1/2 AT squared plus V1T deal. We're going to plug our numbers in. Negative 1.2 is equal to 1/2 negative 9.8 t squared plus 0 times t. Now conveniently, right, anything times 0 is 0, it just goes away. And so we get negative 1.2 is equal to, we can take our 1/2 and we can multiply it by our negative 9.8. There's just two values there, right? They're two numbers. We can multiply two numbers together whenever they're multiplied like that and simplify it that way. And 1/2 of negative 9.8 is going to be negative 4.9. We're going to leave our t squared on there. All right. Now, we'll keep going with this, and we need to undo that multiplication by t squared before we can get take the square root of t squared. Right? Before we can get our time, we need to get t squared all by itself. We'll undo that multiplication by dividing each side by negative 4.9. Then we're going to get t squared is equal to whatever 1.2 over 4.9 is. If you have made a mistake with signs earlier and you forgot that sign, this right here is going to be the point where you end up getting a negative number that shouldn't be. You'll never end up with a negative number for time. 1.2 over 4.9 gave us 0.245 seconds. All right, that's t squared though, so I'm not done. Got to take the square root of both sides to get t by itself. And when we take the square root of 0.245, we're going to get a larger number, because anytime we take the square root of a number less than 1, we will get a larger number than we started with. That gives us t is equal to 0.495 seconds. Take that, plug it in here, and now we have enough information to solve on our horizontal side. We have the equation x equals vt. We know x was 3. V is what we're looking for, and t was 0.495 seconds. Plug it into my equation, divide each side by 0.495, and that will give us a larger number yet again. 3 over 0.495 is our velocity of 6.06 meters per second. And I bet if you had rounded that to 6, you would have been A-OK. All right. Now we'll move on to our next question. If you'll allow me a moment here to get myself organized. I don't plan to edit this later. Since I'm already late on getting you this video, my apologies. All right, our next problem. A ball is rolling off the end of a table 3 meters above the floor. All right, well, if we're talking about that ball rolling off the table, it's 3 meters up, right, above the floor. That's going to tell me it's the vertical direction. So that's going to fall 3 meters. I'll make it negative. Before I start any of these problems, I can make V1 0, and I don't need V2. All right, so we dealt with rolling off the end of a table 3 meters above the floor. The above is really the important part there. It's 3 meters above the floor. That's telling us it's vertical. If the ball rolls at a horizontal speed of 0.6 meters per second, well, that'll tell me I should go plug that in for velocity horizontal here. 0.6 meters per second. We want to know how far away the ball lands from the base of the table. What is our horizontal distance, xh? All right, well, we're going to follow our procedure here. We start by we look at the sides and we see if we have enough information to solve for time, right? That's always going to be our first step. So I like to start with horizontal. Horizontal is x equals vt. And I need both pieces of information if I want to start here. I don't have both pieces of information. I'm going to have to start on the slightly more complicated vertical side where we use x equals 1/2 at squared plus v1t. So when we're over here, we'll just go and plug our numbers in again. -3 equals 1/2 negative 9.8 t squared plus v1t, and v1 is 0, so we can just plug a 0 in right there. Now what we're going to be able to do, right, is as we come through, we can simplify that away, and we can multiply those together. And now we can just continue to simplify. Negative 3 over negative 4.9 is going to get t squared being 0.6 seconds. If I take the square root, I'm going to get t of 0.78 seconds. Pretty close. We'll plug t into 0.78, and now we can do the x equals vt component. .6 times 0.78. And if you rounded, you'll probably get something closer to 8. That's going to give me 0.468 meters when I multiply those together. There we go. That's all there is to that one. All right. We're just going to keep cruising through these problems. Common things to look out for are just making sure that you have your variables on the right side of the information, right? Don't accidentally put your horizontal information with the vertical stuff. If you are stuck, draw yourself a picture and put some of those numbers on the picture where they seem like they should go. It's going to help you to make sure you're getting your information in the right places. All right. Well, an activity that we're not going to do in our energy unit because we're, this, is that you roll a ball horizontally off a table and predict where it will land. This is very similar to the last problem, so we're just going to kind of cruise through it at high speed here. The table is 1.94 meters tall. We want to know how far away that marble lands. And we know that marble is going 0.7 meters per second. So this is data that we took from when we do this activity in person. So we would find this information if we were in the classroom doing this together. We'll use x equals 1/2 at squared plus v1t for our vertical side. And I'm just going to take some shortcuts here. I'll plug in for x. I'm going to simplify half of our 9.8 right off the bat. And v1 times t is going to go away because v1 is 0. We'll divide each side by negative 4.9. We'll get t squared is equal to 0.396. Square root of that is going to be 0.63 seconds. Plug that in, and now we can use x equals vt to figure out how far away that marble landed. If you notice that problem seems a lot like the problem before it, I'm just going to tell you now, there's only so many ways we can change these problems, right? We can change the setting, but generally you're always either going to have the vertical height or you'll have the horizontal distance and horizontal velocity. It's really kind of only a very limited number of types of these problems we can give you. So once you get them practiced, you should be in good shape. All right. Because our projectile is on Earth, we're only launching them horizontally, not up as well. We already know the acceleration, etc. Right? The vertical shortcut that we're talking about here is simply this. I showed it to you before. X equals 1/2 at squared. The other even shorter portion of that is x equals negative 4.9 t squared, as long as we're staying on Earth. So that's going to be handy, and we can use x equals negative 4.9 times t squared in our following problems. All right, number 5 here, we've got a soccer ball, and it is kicked off the Grand Canyon horizontally with a speed of 2.5 meters per second, and it lands 52 meters away. How tall is the Grand Canyon? There's our question, right? V1 was 0. Don't care about V2. And now we're going to go and check. Where can we start? Can I start on the horizontal side with x equals Vt? Well, this time I can. I have xh and Vh. 52 equals 2.5 times t. All right. So now I can solve. Divide each side by 2.5. And 52 over 2.5 is going to be 20.8, which is actually a lot of time to be in the air for. It is the Grand Canyon, after all. Things take a long time to drop to the bottom. Over here, we can now use our shortcut, x equals negative 4.9 t squared. And now we can plug our numbers in. X equals negative 4.9. And now our time is 20.8 squared. Now keep in mind, 20.8 is the number you want to square, not the combination of the two of them. For instance, we have negative 4.9 now, times 20.8 squared is 432.64. Now we can multiply that by 4.9. We had a negative 4.9 to get negative 2,119.936 meters, or 2,120 meters. Now, what you can do, right, is you can drop that negative sign, because that's how far that ball fell, and we want to know how tall the Grand Canyon is. I'm guessing your teacher will not be picky whether you have a negative there or a positive. I know I'm not. All right, last problem. A car is moving along at 24.5 meters per second on a road along the side of a cliff. Dangerous curve is ahead, right? You want to look out for those when you're driving near a big drop off. Driver knows they're going too fast, they bail out of the car, right? They ditch it. They probably should have paid better attention. Their car goes flying horizontally off the end of the cliff, which is 65 meters above a river. So we've laid this one out a little differently for you, but we still want you to go through with this. All right, how long is the car in the air? Well, that's always our vertical information. Don't care about V2. We know V1 was 0. A is negative 9.8 meters per second squared. And we're looking for that, or actually, we know the height. That was a 65 meter tall cliff. Now we need time. We can use our shortcut, x equals negative 4.9 t squared. And now we can say 65 equals negative 4.9 t squared. Divide each side by negative 4.9. We fell that 65, so we can make it negative. And we're going to get t squared is 13.26. Take the square root of both sides. And we get our time to be 3.64 seconds. Once we know our time, we can go and plug that time into the horizontal information. We know that that car was driving at 24.5 meters per second, and we want to know how far out from the base of the cliff the car reaches. Our equations, x equals Vt for all horizontal movement. X equals our 24.5 meters per second times the 3.64 seconds it traveled at that for. And we're going to get x to be 89.2 meters. So if you were divers going out to look for this car after it sank in a lake after going off the cliff, and you knew that speed limit was about this, you could figure out that probably in a relatively straight line from where it went off the cliff, you should start diving and looking for that car 89.2 meters out. Or you don't look for it at all. But generally when you pollute like that, someone's got to go get that car out of the lake. It's a hazard. All right, that is your formative assessment. I hope it was helpful. Please email me or your teacher with any questions you might have. Have a good one.